Pidhai kar lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai kar lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is the electric field due to a uniformly charged thin spherical shell. Here close thermal post-postman aside symbolies begin. For a thin spherical shell of radius r carrying total charge q, spread uniformly over its surface, the field at a point outside the shell, at distance r from the center, with r greater than r, is genuinely given by E equals kq over r squared, exactly the same formula as a point charge q placed at the center. This genuinely elegant result comes directly from applying Gauss's law with a spherical Gaussian surface of radius r, by symmetry. The field is genuinely radial and has the same magnitude everywhere on this sphere, so it comes straight out of the flux integral, giving E times 4 pi r squared equals q over epsilon naught. For a spherical Polashi Ravayo accent filad, SIPHONYES and of its Sorvarnan total charge q, spread uniformly over its surface, the field at a point outside the shell, at distance r from the center, with r greater than r, is genuinely given by E equals kq over r, the same formula as a point charge q placed at the center. This genuinely elegant result comes directly from applying Gauss's law with a spherical Gaussian surface of radius r, by symmetry. The field is genuinely radial and has the same magnitude everywhere on this sphere, so it comes straight out of the flux integral, giving E times 4 pi r squared equals q over epsilon naught, which rearranges immediately to the familiar point charge like formula. This means that from outside a uniformly charged shell is genuinely indistinguishable from a point charge carrying the same total charge. For a point inside the shell at distance r from the center, with r less than r, the field is genuinely exactly zero everywhere inside, no matter how close to you get. This follows direct law 2, since a Gaussian sphere, polocrafol, postmanent mitana zero charge, all peer postamian p acting mukamala vatsila y Philadelphia p saphone and Philadelphian firut, pace philip pisha philophone, atafoju, poj, with zero enclosed charge, through this inner Gauss sphere is genuinely zero, and by the same symmetry argument as before, this forces E itself to be exactly zero throughout the entire interior region. Here clois thermal pe sahising Paschimi Afriki Rendinavia Philofoju is banking Kajanjinilinian beneath the shell's own surface, not just at the exact center. The single most frequently tested G skill here is genuinely sketching or interpreting the complete E versus R graph for a charged shell. The field stays exactly zero from the center out to R equals R, then jumps discontinuously right at the surface, and falls off following the familiar 1 over R squared curve for all R beyond R. This specific discontinuous jump exactly 80 the shell's surface, is a frequently tested conceptual point. A frequently tested trap involves genuinely comparing this result to a uniformly charged solid sphere instead of a hollow shell. For a solid sphere, the field genuinely does not jump to zero inside. It instead rises linearly with R from the center up to the surface, since a solid sphere has charge distributed throughout its volume, not just on the surface. So a Gaussian surface inside a solid sphere genuinely does enclose some charge growing with R. Always genuinely check carefully whether a problem describes a hollow shell or a solid sphere before sketching the field pro. Let's recap. Outside a uniformly charged thin spherical shell, the field is E equals kq over r squared, exactly like a point charge at the center. Inside the shell, the field is exactly zero everywhere, since a Gaussian surface drawn inside encloses no charge at all. The complete field profile jumps discontinuously right at the shell's surface, and this is genuinely different from a solid sphere where the field instead rises linearly with R inside. Distinguishing shells from solid spheres is the key skill this topic tests. That's deal due to a spherical shell. Keep the zero field inside result and the shell versus solid sphere distinction sharp. They're the fastest way to handle both conceptual and numerical questions on this topic. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.